Hey YouTube, it's JP Dillon with another vintage machine for repair. Today's victim is a Kenwood 7400 receiver, kr-7400, made about 1975-76. This was during the generation where Kenwood made pretty good things. As you can see, it's got a robust power supply, ample heat sinking, everything is very well systematically laid out. You've got your power supply here, your power amplifier, your tuner assembly, the stereo multiplexer, and underneath you've got the input selector, phono preamp, main preamp, etc. And as you can see, the wiring is all nice and tightly bundled. It's very neat looking. So these I regard as some of the better machines out there. This one's come in because for a time the protection relay was clicking off. No transient, no popping or nothing, just sound goes bye-bye. So we're going to troubleshoot this machine and figure out what's going on today. As you can hear, the symptom is lights up, no sound. It'll stay there for all eternity in protect mode. As you can see, we're flatlined here as far as the signal, even when I crank the volume all the way up. So let's begin. There are a few causes that will cause this symptom. First and foremost, check your power supplies, make sure you have symmetrical voltages, check your regulated supplies, and check your amplifiers. So let's get to it. So grab your trusty multimeter, and the first thing we're going to do is go to the collectors of the output transistors, which can just be the case. And we've got, let's see here, we've got plus 43. And we've got minus 43, so we're good there. Main power supply is alive. And here's the power supply board. Let's see if I can get the meter over here so we can see it. Okay, and let's go to our regulator transistor, which is up here. We've got our 12 volts for the tuner. And let's come up to the dropping resistors here. We got 20 volts for the phono preamp. There's the 43 unregulated coming in. Okay. Now let's go down to our emitter resistors here, which are the little white things. And we're going to see if we have an offset. 10 millivolts, that looks good. Minus 13 volts, there's your problem. And it's bobbling around, so that tells us we've got a transistor that's failing. So the next thing we'll do, since we've pinpointed the problem, I'm going to take one of the leads off of my scope here, and we're going to hang it across the emitter resistor and see what we get. Well, would you look at that? So we've got an absolute ton of noise as well as a DC offset. But let's see if it passes signal. If we go to the front panel here and select auxiliary, which is where our signal generator is plugged into, yeah, so far it's not passing signal. Make sure, yep, the pre-out main in down here is switched on. It's on normal. Oh, and the left side there too. Look at that. So both sides are kind of shitty. Let's confirm that with our scope. Okay, well this is apparently the left channel, which is what the top scope thing looks like. So what let's do, when it does come out of protect, it sure is noisy. Now this machine has lived near the beach, and as you remember from the other video I had with the Yamaha receiver that had maritime exposure, this could also very well be a a problem. Now before you go diving into the amplifier, since this has a pre-out main-in separator, we're going to do the smart thing and we're going to isolate the two. So down here is a little switch with a keeper on it. And take the keeper off. And we're going to separate them. Yeah, we still got noise. If I reconnect here, no, doesn't change it. Okay, so now that we've separated the preamp and the power amp and we still see the symptom, that pretty much guarantees us that the problem is in the power amp. And if I come over to this channel, looking at the bottom half of the scope, it's just a flat line clean, so that's not our problem. So this is apparently the left channel because I'm getting equal distortion here now. Okay. So, let's turn this off. Let's get some light on things. And we're going to grab a bleeder resistor and bleed down the power supply, and then we'll poke around on the amplifier. Now, a bleeder resistor can be something as simple as just a wire in this. So I've got a 3.9 ohm 10 watt. You may wish to use a 100 ohm 5 watt if you're just doing very slow bleed downs, like leave it there. But in this case, we want to be kind of quick. So you can go right to the collector of the output transistor, touch it there briefly, with the other end connected to ground. And then, of course, do the smart thing and check to see that your voltages are gone. 100 millivolts, minus 108 millivolts. Okay. So, as I mentioned before with the maritime air, we're going to get some bright light on this. And we're going to look at bottoms of the transistors, starting with the differential amplifier pair. And let's see if I can zoom in here so that you can see it. Nothing scary looking there. Again, you'll see those white crusty deposits. So let's look at the other one. Get some light on it. Doesn't look like there's anything there. Come on, focus. Okay, so we're good there. Let's check the bottom of the Class A driver. Now there's some corrosion. I don't know if you can see it very well. Come on, focus. Yeah. See around the edge of the transistor there's some of that white maritime air deposit crap. So we'll be sure to scrape that one. And then let's check our limiters here for garbage. See, we've got some crap on that one too. So what we'll do is we'll scrape all of these. Just get a really sharp X-Acto knife and abrade the bottom, especially between the leads. And we'll scrape all the corrosion off and then see where we go from there. So we'll pause while I do that and then we'll retest. Okay, so I've scraped the transistors in that channel. Let's see. Plug it back in here. Ah, it comes out of protect. Let's go to our load screen here. Cool. No noise. That's good. Let's switch in the preamp. Okay, so I've got that there. I've got no right channel though. And we've got some nasty crossover distortion there. Look at that. Big notch. Okay, so I need to figure out why. Make sure this is all hooked up right. Let's go to another source. Okay, so no matter what, no right channel. That's a little annoying. Let's see if there's a mono switch here. Ah, there we go. And when I reverse it, it switches sides. So there's something in the inputs selector that's wonky. Let's mess around with our tape monitor switches and stuff. That's something else we got to troubleshoot. But hey, it's not making scary transients, so that again proves that maritime air deposits can be very destructive. As a preemptive strike, I'm probably going to scrape all the transistors on the right channel that we didn't do, and then we'll figure out what's going on with the dead right channel, no signal. And just as a quick test here, let's grab this and go to our volume control and see if it shows up at the volume control. Okay, so we got one channel there. I believe this is the other balance control here. Okay, so it's not at the volume control. So we need to troubleshoot why our right channel is missing, because that's no good. So let me scrape the remaining transistors, and then we'll get to troubleshooting why we don't have a right channel. Okay, so we have both channels. If we plug into the tape monitor, I'm on tape monitor A. And likewise, if I go back here and we switch over to tape monitor B, again, we have left and right. And we are in stereo mode, and going through all of the modes, we still have both channels. However, going back to auxiliary phono or switching over to the radio, we've got nothing except the one channel here. Oh, well, I got that back too. Okay, well, maybe that tape monitor switch is crummy. Maybe something wrong with the jack panel. I don't know. It's working now. I might look into that if it becomes temperamental again. So, now that we've got both channels, let's run up the amplifier. I got another problem. Positive half waveform, it gets clipped off. So either there's an open base resistor for one of the output transistors on the NPN side, or one of the output transistors simply is starting to open, because you're only getting about maybe 5 watts out of it before it clips out. And let's just feel the drivers here. The PNP is cool. The NPN's kind of cool. So that's more interesting things. Let's see if we can dig into that too. So let's check some output transistor voltages here and see if we see anything peculiar. Let's see here. We got 15 millivolts there. You got minus 0.4 of a volt there, so that's the biasing for the PNP. Emitter for NPN. So going to the base of the NPN, there's no drive. We got high voltage, no drive. That's for the base of the NPN. That's the emitter for the NPN. That's the base for the PNP. That's the emitter for the PNP. And then we got the high voltage for the PNP. So it's kind of like I thought. The base on the output transistor isn't getting a drive. So if we come up here to the driver transistor for the NPN, not getting enough drive for that either. Only 0.2 of a volt on that base. That ain't enough. So something is wrong in the driver stage. I've got high voltage on it, but nothing to drive it. So what we need to do is look at the fusible resistors which feed the driver stage and the outputs, make sure they're not open. And then check the Class A driver and make sure that it's putting out the proper, I think it's about 1.2 volts is what it wants on the collector of the Class A, so let's check that. Okay, so back to the resistor thing. This 4.3 kilo ohm resistor ain't 4.3 anymore. It's about 36K, so that ain't gonna do it. Whereas if I go over to the working side, and we clip on here momentarily, and we measure this, come on, we've got 4K. So we need to replace that resistor, and then we'll retest. That definitely is open. That's likely what feeds the current to the Class A device. So let's get cracking on that, and then we'll retest. So here's the resistor out of circuit. There's just 330K. It's supposed to be a 4.7, 4.3, something like that. Color code escapes me for the moment, but let's pull one out and pop it in the circuit and see what happens. Okay, so now we got that resistor in there. Let's power it up and see if it flies or fries. Usually resistors open for a reason. Okay, goes click. No more crossover distortion, that's good. It's nice symmetrical power. And let's adjust the input level. Close to symmetrical clipping. I'm not going to complain too much, that's pretty damn good. So there we go, we've got nice symmetrical clipping. It's about, it looks about like 50 watts. Something like that, on 2 volts per division, 1, 2, and we're on a times 10 scale. Yeah, about 19, 20 volts RMS there, so about 50 watts. Cool. So that's working. And as you can see, when I jiggle the tape monitor, it does want to drop one of the channels. So we need to clean the piss out of that. We'll clean all the rest of the switches and controls and resolder the lamps and do the setup adjustments, and this sucker's done. So let's get to it. Now, as far as treating switches and controls, I've mentioned it over and over again. Keg deoxit DE5, get some. As far as rotary controls, just spray the contacts and rotate the switch a bunch of times. Toggles, look for some kind of opening. These are nice and easy because they're obviously very visible. So that's nice. Get the fluid in there and work them about. With potentiometers, they will either have a little vent on top like these ones do, that little hole, squirt it inside there, or simply squirt it wherever the leads protrude. On some potentiometers where things are sealed, there's not a whole lot you can do. You might drill it out, but then you'll get metal shavings inside, so not the best idea either. So we're going to deox all these things and then do the final setup and tests, and then this thing can go home. So now that everything is deoxed, I want to bring something else to your attention on these kenwoods. A lot of kenwoods have power supplies that run really hot. Like this board here. You can see the darkened areas around the dropping resistors. If you see that on the other side, it's almost always true that the soldering has gone to crap, and that's true with this one here too. Sorry, I'm so jittery today. I'm having nerve problems, so I can't really hold the camera steady. Check the regulators, haven't come loose. We're going to resolder those loose connections. And while you're in here, if you have an ESR meter, definitely check the capacitors, make sure they're still good. Especially ones right next to a heat source, like this little blue guy here next to the dropping resistors. He's probably tired. Capacitors don't like areas of high heat, high voltage, or high frequency, and if you combine them all and above, it will die quickly. So let's get our ESR meter, and I'm going to check a few of these and make sure that they're good, and any that aren't I will replace, and then we'll finish up. Okay, so we got our board all soldered up. Got those resistors redone. Those are nice and pretty looking. Touched up a couple of other connections too that were looking kind of sad. So now, let's fire this thing up. Got nice illumination of the lamps there. Let's double check this. Lamps come on, that's cool. Alright, and we've got a nice fat signal here, good. So on the kenwoods, the DC offset is simply determined by the matched beta of the differential amplifier transistors, so there is no offset adjustment on this. However, if the offset was within reason, we will approach adjusting the bias. And let me show you how to do this the right way, because a lot of times people will do it the wrong way and their probe will slip and they'll blow the frickin' thing up and then they'll be in a world of hurt. So first of all, we're going to get the machine on its side. Excuse me here a moment. Okay. And here you have the underside of the board. Now, to take a bias measurement, you want to look across the emitter resistors. And an easy way to do that is just take a look at the board and follow where they are. And in this case, it looks like pin 7 and pin 8 are the emitter junction points. So this is a little bit close here, more so than I'd like to that. Let's bend that away from that without causing a short. Okay. And let me get my probe that fell on the floor. So let's go to number 7. Insulated probes are your friend. And we're going to go to millivolts on our meter. And touching the other emitter junction, we have 53 millivolts. That's a little high. That should really be about maybe 20 to 25. I think that's a little bit excessive. So the easiest way to do this on the fly is get another test lead, hook it up to the test point. Excuse me. Just going to do this here real quick. And okay, so now that we're hooked up, we're going to get an insulated tool, which I've so cleverly labeled adjust. And while watching the meter and adjusting the bias, we're going to go down to about 20 millivolts. That means that with a supply voltage, let's see here. I believe the service manual calls for 20. Oh, that tool isn't completely insulated. Okay. let's switch tools here. When you see the bias jump like that, when you're adjusting it, your tool isn't insulated and you're causing an oscillation. Okay, so now with an insulated tool, now it adjusts correctly. Alright, so 20.7, that's pretty good. Wait another 15 minutes, allow it to restabilize, and then adjust again. So let's take our probes and go to the other channel. And on this one, on the right channel, looks like pins 18 and 17. And this one's running about 41.8, still a little high. So let's turn this down. Okay, 20.4, that's good. Alright, and then we'll come back here and do a mild power of about 1 watt and check and see that we have no crossover distortion, which we don't. If you're uncertain of the bias setting, you want about on a modern solid state receiver, you want about 0.45 to 0.5 volts across the base emitter junction. If you can address those 2 points there and you don't know the value, that's a good value to set it to. So this is good, and now what we'll do is we'll crank it up again. And we're going to test for power output to be sure what it is rather than just guessing. So we're going to turn the volume all the way up and then adjust the signal to where it just begins to clip, and then back off ever so slightly. And then what we'll do is we'll turn our AC meter and measure across the load bank, which in this case is 2 big fat power resistors, and we'll measure the voltage, which is 20.95. That's about 52 watts per channel. Multiply 20.95 times 20.95 divided by 8. It's pretty close to what it is. So the last thing that we'll do is we'll check the tuner and then we'll button this thing up. Oscillator seems to be in alignment. Pretty selective. Good sensitivity. Okay. So this thing's done. So this was servicing a kr-7400, and as you can see, as I'd mentioned before with the Yamaha video, the maritime air leaves deposits on transistors that will cause all sorts of issues. But above and beyond that, there was another embedded amplifier problem which we discovered, feeding the driver section, open resistor causing a lack of current, underbiasing, and distortion. And then we resoldered the power supply, treated the switches and controls, and checked the tuner. On these ones, you can see they have a multi-tiered pulley, and depending on how the tuner is laid out, they'll put the string on one of these steps. If you see the string starting to jump, put a very, very fine oil on here. Fine like deoxit fader lube fine. And that will keep this from jumping while at the same time maintaining no slip. Also, it's true, another thing to check, this machine didn't have it, but the protection relay down here, if abused, will go bad. And what we do is we raise the sensitivity of the scope and tap on the relay, and if the channel drops, you need to burnish that relay. You can wiggle it, and I can get a little bit of flutter here, but it doesn't want to drop. You can take these apart You can pull the relays out, take the cover off, and burnish the contacts. It's pretty self-explanatory once you get it off of the board. So I'll leave that to you guys. Maybe I'll do a video on that later. But anyway, this will be a nice machine. I think the owner will be very happy with it. It's a pretty good thing, and it should last him a little while. If you do live near the ocean, don't leave your machine near a window. Cover it when it's not in use, or if it's in a cabinet, make sure the doors are closed, because again, maritime air is murderous on machines like this. But I hope you guys enjoyed the video. If you've got a 7400, maybe this will help in servicing it. In any case, more videos to come soon. Thanks for watching. Have a great day.